The ocean is a vast interconnected system of currents. These currents act like the Earth's circulatory system, moving water around. They regulate temperatures, weather patterns, and marine ecosystems. Currents help distribute heat from the equator to the poles. This process is crucial in maintaining Earth's climate balance. Ocean currents also play a major role in carbon storage. As the currents move, they pull carbon dioxide from the atmosphere. They then store this carbon in deep ocean waters for centuries. Without ocean currents, the Earth's climate would be dramatically different. These currents are driven by wind, salinity, and temperature differences. The most well-known current is the Gulf Stream. The Gulf Stream transports warm water from the tropics to the North Atlantic. The cold water in the poles sinks, creating a continuous cycle. This cycle is known as the thermohaline circulation. But there's a new player in the game: climate change. Rising global temperatures are starting to affect ocean currents. The natural systems that drive these currents are being disrupted. Increases in temperature affect the density of seawater. As the sea surface warms, the warm water stays at the top. This creates a change in how the water moves and circulates. Ocean currents depend on the difference in water temperature. As temperatures rise, the water's ability to sink and flow decreases. This slowing of currents can have a profound impact on climate systems. But it's not just the temperature that's changing. Climate change is also affecting salinity levels. The melting of polar ice caps is adding fresh water to the oceans. This reduces the salinity in areas that were once saltier. Changes in salinity disrupt the normal flow of ocean currents. In fact, some currents are already showing signs of slowing down. For example, the Atlantic Meridional Overturning Circulation, AMOC, is weakening. This current is vital for the regulation of climate in Europe and North America. A weakened AMOC could lead to colder temperatures in Western Europe. At the same time, it could result in warmer temperatures along the eastern coast of the U.S. These changes could drastically alter weather patterns across the globe. So, what's the cause behind this disruption? Global warming is primarily caused by the accumulation of greenhouse gases. These gases trap heat in the atmosphere, causing the planet to warm. As the planet warms, ocean temperatures rise, which impacts currents. More heat means more energy in the ocean system, causing changes. This disruption is a warning sign of what could happen if we don't act. The cooling of the oceans, once thought to be a natural cycle, is now accelerating. These changes can have wide-reaching effects on marine life. Marine species rely on predictable ocean currents for migration and reproduction. Changes in these currents can alter habitats and food availability. So, it's clear that ocean currents are a key part of our climate system. As climate change continues to impact ocean currents, the effects are becoming more apparent. One of the most concerning consequences is the disruption of regional climates. The Gulf Stream has already shown signs of weakening. This iconic current is slowing down. If it continues to weaken, Europe could experience harsher winters. The temperature difference between the warm Gulf Stream and cold waters will diminish. This could lead to an unpredictable and more extreme climate in the region. Similarly, the slowing of ocean currents can affect rainfall patterns. When currents slow down, they disrupt the natural movement of water vapor. This can lead to changes in precipitation, with some areas becoming drier. At the same time, other regions might experience increased rainfall and flooding. For instance, the slowing of currents in the Pacific Ocean can impact rainfall in the U.S. This disruption has already been linked to more intense hurricanes and storms. As ocean currents weaken, tropical storms can become more powerful. A warmer ocean surface provides more energy for storm development. Hurricanes, typhoons, and cyclones could intensify in strength and frequency. In addition to storms, the shift in ocean currents also affects sea level rise. Melting ice caps and glaciers are already contributing to higher sea levels. As ocean currents slow down, water begins to accumulate in certain regions. This can exacerbate coastal flooding and lead to the displacement of communities. The rise in sea levels threatens low-lying islands and coastal cities. As the ocean warms and expands, it takes up more space. Cities like Miami, New York, and Tokyo are particularly vulnerable to these changes. But it's not just the coastal cities at risk. The entire global climate system is interconnected. When one part of the ocean slows down, it affects the global circulation system. This could trigger a cascade of climate disruptions across continents. Changes in ocean circulation patterns can shift the locations of heat. This may cause some regions to experience more extreme temperatures. For instance, the Arctic has been warming at twice the rate of the rest of the world. This rapid warming has already caused the polar ice caps to melt. The melting ice leads to a decrease in the Earth's albedo effect. Ice and snow reflect sunlight, keeping the planet cool. As more ice melts, darker ocean water absorbs more heat, further accelerating warming. The cycle of warming, melting, and slowed currents creates a feedback loop. This loop accelerates climate change, making it harder to reverse the effects. The impact on marine ecosystems is another critical concern. Species that rely on cold water currents, such as certain fish and whales, are in danger. Warmer waters cause some species to migrate to cooler areas. This can disrupt entire ecosystems and food webs. For example, the migration of plankton could affect the entire marine food chain. As plankton populations move, animals like fish and whales may not have enough food. This imbalance can lead to the collapse of local fisheries and economies. The global fishing industry, which provides food and jobs for millions, could be severely impacted. These changes show how interconnected ocean currents and the climate truly are. The disruption of ocean currents is not just a climate concern, it deeply affects marine ecosystems. Marine species are accustomed to the stable conditions provided by these currents. But as currents slow and shift, these species must adapt or face extinction. Many marine animals rely on predictable current patterns for migration and feeding. For example, sea turtles depend on currents to guide them during their long migrations. Changes in these currents can lead to disorientation, preventing them from reaching breeding grounds. Similarly, whales that follow currents to locate food may struggle to find nourishment. The shift in ocean temperatures and currents also disrupts coral reefs. Coral reefs depend on a balance of water temperature, salinity, and current flow. Without these stable conditions, corals become stressed and more susceptible to disease. Coral bleaching occurs when corals expel their symbiotic algae and water gets too warm. The loss of corals impacts thousands of species that depend on them for shelter and food. The slowing of currents means nutrients are not being carried efficiently to these reefs. Nutrient-rich waters are essential for maintaining healthy reefs, and without them, reefs die. Fish populations that rely on these ecosystems for survival are then affected. A lack of nutrients disrupts their reproductive cycles and growth rates. Some fish species may move to cooler waters, but many won't survive the journey. Others, like plankton, may be unable to thrive without the nutrient flow provided by currents. These disruptions have cascading effects on entire marine food webs. For example, without plankton, the small fish that feed on them will suffer. This causes a ripple effect up the food chain, impacting larger predators. As fish populations dwindle, fishermen's livelihoods are at risk. But the problem doesn't stop there. The warming of oceans also causes acidification. Increased carbon dioxide levels are absorbed by the ocean, making it more acidic. Acidic water harms marine life, particularly creatures with calcium carbonate shells. Species like clams, oysters, and corals struggle to build their shells in acidic water. This weakens their ability to survive and reproduce, threatening their populations. The loss of these species affects entire ecosystems, including human economies. For many coastal communities, seafood is an essential part of their diet and economy. As ocean currents shift and species disappear, food security becomes a major issue. The oceans also provide vital services, like carbon sequestration, that are now threatened. Ocean currents help regulate the global climate by moving carbon into deep waters. As currents slow, less carbon is sequestered, exacerbating the greenhouse effect. This means that not only marine life, but also the entire planet is at risk. These interconnected challenges show just how crucial healthy oceans are. But there's still hope if we take immediate action to reduce emissions. Protecting marine ecosystems, from coral reefs to fish populations, is essential. Stronger regulations to curb carbon emissions can slow the warming of oceans. Protecting marine protected areas can help preserve biodiversity and build resilience. Restoring damaged coral reefs and establishing new marine reserves can make a difference. Local communities can support sustainable fishing practices to protect marine life. Ocean conservation programs must focus on restoring the health of ocean currents. By addressing the root cause, climate change, we can begin to restore balance. Global cooperation is key in tackling this issue. No country can do it alone. Together, we can protect our oceans and ensure a sustainable future for marine life. The impact of climate change on ocean currents is undeniable, but solutions are within our reach. The key lies in global cooperation and the collective will to act. Tackling climate change head-on is the only way to address the disruption of ocean currents. Reducing greenhouse gas emissions must be our top priority. This can be achieved through renewable energy sources, like solar and wind power. Transitioning away from fossil fuels will not only slow global warming, but also protect ocean currents. Governments play a critical role in this transformation. Policies that promote clean energy and carbon reduction are essential for the planet's health. Global climate agreements, such as the Paris Agreement, must be strengthened and adhered to. Every nation must commit to reducing its carbon footprint to slow the rate of ocean warming. In addition to cutting emissions, we need to invest in ocean conservation. Expanding marine protected areas, MPAs, can help restore balance to the oceans. MPAs act as sanctuaries where marine life can thrive without the threat of overfishing or pollution. These protected areas allow ecosystems to recover, ensuring the survival of vulnerable species. Restoration efforts should focus on rebuilding critical habitats, such as coral reefs. By using restoration technologies, we can help reefs recover from bleaching events. Coral restoration involves transplanting resilient coral species to damaged areas. These resilient species can better withstand temperature fluctuations and acidification. It's also vital to address plastic pollution, which exacerbates the effects of climate change. Reducing plastic waste in oceans prevents further harm to marine life and ecosystems. Governments must implement stronger regulations on plastic production and disposal. Promoting alternatives to single-use plastics will help reduce the burden on the oceans. Recycling systems must be improved, making them more efficient at sorting and processing waste. Supporting innovations like biodegradable plastics can reduce long-term environmental impact. Public awareness and education are also critical in the fight against ocean degradation. People need to understand how their actions, such as waste disposal and consumption, affect the oceans. Schools, media, and NGOs can work together to spread awareness of ocean conservation. Individual actions, like reducing plastic use and supporting sustainable brands, are also essential. The role of businesses is crucial in this movement. Companies must prioritize sustainability in their production and supply chains. Eco-friendly packaging, waste reduction, and green energy use are steps businesses can take. Furthermore, innovations in technology can help mitigate the impact of climate change on oceans. Ocean-based solutions, such as carbon capture and storage, offer promising alternatives. These technologies capture CO2 from the air and store it in ocean depths. Advances in ocean science can also improve our understanding of ocean currents. By studying the effects of climate change on currents, we can better predict and adapt to changes. International research collaborations can help identify effective ways to protect ocean currents. The involvement of local communities is also key to successful conservation efforts. Community-led initiatives, such as beach cleanups and sustainable fishing practices, make a difference. Empowering communities to take action will help protect local marine environments. Governments should support these initiatives by providing resources and funding. A global commitment to the protection of oceans is essential for future generations. Ocean currents may seem far removed from our daily lives, but they impact everything. The health of the oceans directly affects food security, climate stability, and biodiversity. By taking action now, we can ensure that future generations inherit a healthy and vibrant ocean.